Okay, YouTube, in this video we're going to confront how we solve equations containing variables inside of an absolute value quantity. Okay, and so what we'll do is we'll start by considering the equation the absolute value of x equals 3. And when considering this, we say, well, what would the solutions be? You can see that easily we could come up with the fact that either x is a negative 3 or a positive 3 because, well, when you take the absolute value of a number, it's just going to come out to be that positive value of itself. So we say, therefore, when we work with absolute value equations, what we'll do first is we'll basically just rewrite the equation into two forms. So when you see an expression like this, and I'm going to assume a is some positive number that this came out to be, but if the absolute value of x equals a, then either let's rewrite it as x equals a, which is essentially it's just the same equation, same EQ, no bars. And then the second way we'll rewrite it is x equals negative a, which is pretty much the same equation, same EQ, but right side quantity is its opposite, okay? Is opposite. And we say no bars also. No absolute value bars. Handwriting's bad. I'm really sorry, everybody. Let's take a look at a couple examples here. But basically what we'll do is we'll isolate that absolute value and then we'll just rewrite it two ways, which is going to be our method for solving these. So I notice here that I have some expression in x. It's inside this absolute value here and it's equal to 5. So the first thing I'm going to check is that this absolute value is by itself on one of these sides. And I notice that it is. There's no leading 2 out here that we would have to divide both sides by, or maybe like a plus a constant on the side here. So what we'll do is we'll rewrite this in two ways. So the first form, we would say 2x minus 1 equals 5. And what I want you to notice is that we just dropped the absolute value bars, and it's really just the same equation. We'd say either this is true, or we'd say 2x minus 1. Now I dropped the bars again. Nothing changes in this expression. All we do is we just make the quantity on the right its opposite. So now that I have this, we're going to solve both of these equations. And really, you know, because we have the same quantities on both of these equations on the left, we're going to solve them in the same fashion. We can do these all at once. So we would say 2x is equal to 5 plus 2, which is 7. We say 2x is equal to negative 5 plus 2, which means 2x would be equal to negative 3. And then here, we would divide both sides by 2. So we're going to divide both sides of this by 2. And we'd say x is either equal to 7 halves, or x is equal to negative 3 halves. And of course we want to write this in set notation, so we'd say solutions here. Solutions are going to be listed as either negative 3 halves or positive 7 halves. And these would be really easy to go back and check in our original relation up here in the original equation to see that they both satisfy it. So now looking at checkpoint 9, this is really just up here just to show you that we cannot rewrite this equation yet until we get rid of these two values here, because we need to isolate this absolute value quantity. So we'll start by the way we do when we solve a two-step equation. We'll get rid of adding and subtracting first. So we'd say, well, rewriting this, we get 4 times the absolute value of 1 minus 2x. And this is going to be equal to 20 on the right side. And now we'll divide everybody by 4 here, a fourth of those. So our 4's are gone. Looks like we've isolated this absolute value quantity. So we have 1 minus 2x in the absolute value bars, and we say 5 on the right. So now rewriting this, we would say, well, I either get 1 minus 2x is equal to a positive 5, or we get 1 minus 2x is equal to a negative 5. And so we'll go ahead and go through the steps for solving this. We're going to subtract 1 from these sides, and of course we'll do it to both equations. So we get negative 2x is 4, or negative 2x is equal to negative 6. And so now dividing both sides here by a negative 2. Negative 2, negative 2. We get that x is equal to either negative 2 in one instance, or x is equal to a positive 3. So our solutions here would be the set containing either a negative 2 or a positive 3. But that's how you'll deal with absolute value equations. You essentially just rewrite it two ways. Cheers.